Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Okay, lesson seven, still in this beautiful setting in Sicily. Mr. Bernie Sanders has gone home. Now we're on lesson 7, equations for lines using normal segments. Opening exercise. The equations given are in standard form. Ax plus by equals c. So remember that is standard form of a linear equation, and I'll write that up here. Ax plus by equals c. That's standard form. Put the equations in slope-intercept form. So we want to get everything over on the other side. So to get this standard form equation in slope-intercept form, we would subtract ax over to the other side, and that would leave us with by equals negative ax plus c. And then I'd have to divide both sides by b. And that would yield y equals negative a over b times x plus c over b. So that is going from standard form to slope-intercept form, and the negative a over b is our slope m. Whoa. Okay. So here we go. Now, if I just use this, remember, here's my a, b, and my c. If I use this shortcut, I can answer these questions without showing all this work every time. So I'm just going to write y equals, and my negative a, negative 6 over 3 is negative 2. Negative 6 divided by 3 is negative 2. X plus c over b. 12 divided by 3 is 4. And my slope is negative 2. Wow, wasn't that cool? All right, so let's do that again. Negative a, so y equals negative a over b x plus c over b. Well, 14 divided by 7 is 2. So in this case, my slope is negative 5/7. Oh, and it says y-intercept. Well, my y-intercept is my b. So I could say b equals 4, or I could say y-intercept equals 2 in this case, right? All righty. And then on to the last one. Let's use blue. So I'm going to write y equals, and it's going to be negative a over b plus c over b. Now this one had some negatives, so let's clean that up. Oh, I forgot my x right there. So this is going to be y equals negative divided by a negative is positive 2/5 x. Negative divided by a negative is positive plus 7/5. My slope is 2/5, and my y-intercept is 7/5. Doesn't look like a 7, does it? Alrighty. 7/5. So there is numbers 1, 2, and 3 using this rule, if you will. Okay, now we're on to the example. Given point A is 5, -7, and B is 8, 2. Find an equation for the line through A and perpendicular to AB. Okay, well, we kind of did this in prior lesson. Was it lesson 6? Well, what we're going to do is move this segment to the origin. So A is going to end up at the origin. So I have a vector movement, and I need to move the x to -5. So I have to move it left 5 and up 7. So this is my vector direction. So to move A from 5, -7 to the origin, I need 5 minus 5, which is 0. And -7 plus 7 is 0. And that would be my A prime. Okay, and now I need to find b prime. So b prime will be the point 8, 2 moved the same direction. 8 minus 5 brings us to 3, and 2 plus 7 brings us to 9. So our segment is now at the origin, and the other end is at 3, 9. All righty. So find the equation for the line through A perpendicular to AB. All right. Okay, so we're going to need another point. So now we have a segment AB that we move to the origin, but now I want to find a line segment perpendicular to AB. And so let's call it, I don't know, C. Let's call it C. So if A prime is 0, 0, let's call it C prime. Let's move this down here, and we will call it C prime. And C prime is going to be the point x minus 5. We don't know where it is, so it's x minus this, comma, y plus 7. So we're just adding this vector to x and y. All right, so then to make it perpendicular, we need x times x plus y times y to equal 0. So it's going to be 3 times this. So I'm going to write it like this: 3 times x minus 5 plus, and then the y's get added. So it's going to be plus 9 times y plus 7 has to equal 0. This will give me 3x minus 15 when I distribute. And this is going to give me 9y plus 63 equals 0. So then I get 3x plus 9y plus 63 minus 15 is 5348 equals 0. Okay. Then I'm going to solve for y. And we're done. So let me move this up here. So I'm going to leave 9y on the left. I'm going to subtract 3x over to the other side. So minus 3x will make it minus 3x on the right. And I'm going to subtract 48 from both sides. So that will leave 48 over here. Then I'm going to divide everything by 9, leaving y equals negative 1/3 x minus 9 times 5 is 45 with a remainder of 3. Well, 3/9 is 1/3. So it would be y equals negative 1/3 x plus or minus 5 1/3. Okay, and if you just wanted to leave this as improper, then it would be y equals negative 1/3 x minus 16/3. So this would be with a b that is improper. Okay, so there's the equation of a line through A perpendicular to AB. Okay, part B, we're going to do the same thing, but now we're going to do it for, let's see, point B. So let's use red here. First thing I always do is find that vector. So B is right here. So to get this to be 0, 0, I need 8 minus 8 to get 0 and 2 minus 2 to get 0. So my vector is negative 8, negative 2. That will give me a B prime of 0, 0. Okay. Find an equation for the line through B perpendicular to AB. Well, now I need to find A prime with this translation. So A prime is going to end up being 5 minus 8, which is negative 3, negative 7 minus 2, which is negative 9. So there's my A prime, negative 3, negative 9. Okay. Now what we have to do is we're working with B and A prime. So the segment that's perpendicular has to be equal to 0 when we multiply the x's and multiply the y's. So our, I don't know, what could we call it? Point C prime in this case, or let's call it D prime this time. So D prime is going to have to be x plus 8. I'm sorry, minus 8, x minus 8, comma, y minus 2. So our vector here tells us what to put here. And then we're just doing this again. X times x plus y times y has to equal 0. Distribute negative 3x, be careful, negative times a negative, 8 times 3, minus 9y plus 18 equals 0. I like to put these in standard form first. Negative 3x minus 9y plus 24 plus 18 is 42 equals 0. Standard form, put into slope-intercept form, we're going to get negative a over b. I'm just referring back up to this. So we want negative, so we have y equals negative a, which is a negative negative 3, over b, which is a negative 9, x, plus c over b, which is going to be negative, so it's minus 2. All right. But then we have this plus 42 here. So, oh, my fault. I did this wrong. Negative a over b plus c, which is 42 over 9. Okay, I just made a mistake there. So there it is, negative 42 ninths. Simplify that, and we get negative 1/3 x, and 9 times 4 is 36 with a remainder of 6. So this can reduce. 3 will go into 42, 3 will go into 9. 3 goes into 9 3 times. 3 goes into 4 once, 3 goes into 12 4 times. So it's 14/3 for my b, negative 14/3. So y equals negative 1/3 x minus 14/3. There's a minus sign there. Let me move that just a little. There we go. All righty. So there are our two equations. So this is really cool. Without graphing something, finding a line perpendicular to a point that doesn't go to the origin. Page 2 brings us to the exercises 1 and 2, parts A and B. Pause the video, see if you can do this, and then come back and see how you did. I'm going to do these a little bit differently. Same concept though. Okay, so I do know my vector to change that is 4, 1. All right, so write an equation for the line u through the perpendicular. So first of all, u prime is going to be 0, 0. And v prime is going to be v minus this. Okay, or v plus this, I mean. So it's going to be 7 plus 4, 1 plus 1. All right, so this just makes that a little bit quicker. And then we want to find a point P prime, and that is going to be x plus 4, y plus 1. All right. So there are our 3 points, and now we just want to find a perpendicular for these. So we're going to say x times x right? Here's our x and p prime, plus our y times our y. Okay, I didn't do any simplification yet. I just left it at this. Now I'm going to simplify this, and it's going to be, this is 11, and it's 11 times x plus 4, which would be 11x plus 44, plus, and this is 2 times y, 2y, 2 times 1, 2, has to equal 0. And I should have that here as well. Combine like terms, 11x plus 2y plus 46 equals 0. And then put that in standard form by, or it is in standard form, put it in slope-intercept form by saying y equals, and if you don't remember, it's negative a over b x plus c over b. So negative a over b x plus c over b. Simplify. And we're done. Okay. Okay, I just realized something here. Let me just point something out to you. I'm going to change this right here. When we're in standard, this is not standard form. In order to get this into standard form, that 46 should be over here. So it's negative. So if I want to use that shortcut I used over here, y equals negative a over b x plus c over b, y equals negative a over x, y equals negative a over b, whoops, okay, if I want to use this, that is when our c is already over on the other side. So this is not in standard form. So if I want to move this over here, I have to think of the opposite here. So this is going to be minus. And with that being said, I need to go back to the last problem I did down here and make that plus. Because if 42 was over here, it'd be negative 42. And negative 42 divided by a negative 9 is a positive 14/3. All right, so I apologize for that there. Now let's continue. B, write an equation for the line through V and perpendicular to UV. So now we're going through V. So I want U to be, okay, so now we're going through V. So I want my V prime to be 0, 0. And I want my U prime is going to become negative 4 minus 7, comma, negative 1 minus 1. So that's my U prime, because we subtracted 7 from 7 to get 0 and 1 from 1 to get 0. So we subtract 7 from negative 4 to get negative 11. So that would give us U prime as negative 11 and comma negative 2. So there's the point U prime. And then we have this P prime, if you will, and that is going to be X minus 7. So what I haven't done here is written my vector out here, and it's just the opposite of what V was to get to 0. So it's negative 7, comma 1. So it's X minus 7, comma Y minus 1. Okay, so now I want to take U, the X values of U and P, so it'd be negative 11 times X minus 7 plus the Y values of negative 2 times Y minus 1 has to equal 0. So this is going to give me negative 11X plus 77 minus 2Y plus 2 equals 0. So I don't make that mistake again with my little shortcut. I am now going to move the constant over the other side. I'll put it in standard form first. So it's going to be negative 11x minus 2y. And 77 plus 2 is 79, but I'm going to move it over to the other side and make it negative 79 because I subtracted 79 from both sides. Now I can put it in slope-intercept form with my shortcut and say it is negative a, which would be a negative 11, which is 11, over negative 2. So I'd make that a negative 11 halves x. And then it's going to be plus c over b, which is 79 over 2. So it's negative 11 halves x plus 79 over 2. All righty. Okay, moving along, number 2. Let's use blue. Write an equation for the line through S perpendicular to ST. So the first thing I'm going to do is find my vector translation, and it's just the opposite signs of what S was. So it's negative 5 comma 4. That'll give us 0, 0 for S. So S prime is now 0 comma 0. T prime is going to be negative 8 minus 5, which is negative 13, comma 12 minus 4, which is 8. And my P, my other point, is going to be X minus 5, comma Y plus 4, coming from this vector, okay? And then we just simply multiply X's and Y's and set equal to 0. See how easy this becomes after you do a few? So it's going to be negative 13 times X minus 5 plus 8 times Y plus 4. And that has to equal 0. So I get negative 13 times x, which is negative 13x. Negative times a negative is positive. 13 times 5 is 65. Plus 8 times y is 8y. 8 times 4 is 32. Equals 0. Putting it in standard form, I get negative 13x plus 8y equals, and I'm taking 65 plus 32 and getting 97, but it is a negative 97 on the other side of our equation. So then I go and I plug it into, I convert it to slope-intercept form, which is negative a, which is a negative 13, or 13 over b times x plus c over b. But in this case, it's a negative over a positive. So instead of saying plus a minus, I'm just going to say minus 97 over 8. So my equation is y equals 13/8 x minus 97 over 8. Okay, and as always, I'll review my work, and unfortunately, I made a mistake here. So I want to subtract 5 and add 4. Subtracting 5 from negative 8 gives me negative 13, but adding 4 to 12 does not give me 8, it gives me 16. So I'm going to put my error in green. So that's going to be negative 13 and 16. X minus 5, y plus 4 is correct. So this is going to give me negative 13 times x minus 5 plus, this is not 8, it is 16. It's my 16 times my y. That is going to give me 13x plus 65, that's correct. But this is going to be 16y. And then 16 times 4 is not 32. 16 times 4 is 64. So I'm going to put 64 here. So then I get negative 13x plus, not 8y, but 16y equals, and 65 plus 64 is 129. So it's going to become negative 129 on the other side. So then when I do this, this 8 is going to become 16. 13 16ths, negative a over b minus my c, 129 over 8, which is not 8 anymore. It is also 16. All right, whoops. So my answer should be, hopefully you got this and said, wait, you're wrong, dude. Yeah, I was. My answer is y equals 13/16 x minus 129 over 16. Whew. Okay, let's extend the page and move this out of the way. Okay, so one more time, we're now write an equation for the line through T. So now we're talking about this point. So I want to move that to the origin. So to move it, our vector is going to be the opposite of these 8, negative 12. That's the vector translation that give us T prime of 0, 0. All righty. And then we're going to look for S prime. And S prime is going to be 5 plus 8, which is 13, and negative 4 plus a negative 12, negative 16. And then we're going to have some point x plus 8, comma, y minus 12. So there's our T prime, S prime, P prime from this. And then we take SP and we find the equation. So we take the x value from S times the x value from P prime plus the y value from S times the y value from P prime, and that equals 0. We distribute. 8 times 3 is 24, 8 plus 2, yep. And then minus 16y, watch your signs. Negative times a negative is positive. And 16 times 12, well, 16 times 10 is 160, plus 2 more 16s is 32, that's 192 equals 0. Putting this in standard form, we get 13x minus 16y, and 104 plus 192 is plus 296 equals 0. Remember, standard form, this has to be equal to a constant, so I have to move that 296 over to the other side. So here's my A, here's my B, here's my C. Putting that in slope-intercept form, you take negative A over B times X plus C over B. And then simplifying that, I'm going to get 13/16 X plus 296/16. Well, half of 296 is 148 over 8. That still reduces, so 148 over 8 is 74 over 4. And that reduces, half of 74 is 37 over 2. And there's our reduced amount. So let me just erase these. And move this here. So my equation is, oops, y equals 13/16 x plus 37/2. Okay, page 3 brings us to the closing. I think it's page 3. Yes, page 3 brings us to the closing. Describe the characteristics of a normal segment. Well, a normal segment is a line segment with one endpoint on a line. So let me draw this. So if I take and I draw a line has an arrow at both ends, and let's make it red. So here is a line. A line segment is going to be just that, a segment that comes off of, that has an endpoint on the line, a line segment with one endpoint on a line. So I'm just drawing up what this is saying. Here's the endpoint on the line, and perpendicular to that line is called a normal segment to the line. So that is the characteristics of a normal segment. Every equation of a line through a given point A, comma B has the form of capital A times x minus A plus B times y minus B equals 0. Explain how the value of capital A and capital B are obtained. Okay. So A is the value. Let me point something out to you, a term you might not have heard before. A is the value of the abscissa. Okay. And that is just a fancy term for the x coordinate. And the y is called the ordinate. I rarely, if ever, use these terms in class, but nothing wrong with knowing them. So A is the value of the abscissa of the image of the endpoint of the normal segment that does not lie on the line after the figure has been translated, so that the image of the endpoint that does lie on the line, the point of the perpendicularity, is at the origin. So basically what this is the translation of, like if we wanted to know if these two are perpendicular, we would move this point to the origin, and that comes from this a times x minus a. And also for the b portion would come from the ordinate. So let me just bring that in here. So b is the value of the ordinate. So there's that word right there, ordinate, of the image of the endpoint of the normal segment that does not lie on the line after the figure has been translated, so that the image of the endpoint that does lie on the line, the point of perpendicularity, is at the origin. Okay, so that is where this comes from. Just the translation using the vectors that we used in the video. All righty. Okay, page 4 brings us to the end of lesson 7. Go to your problem set.